Today's lesson is box plots, our learning target. Make sure you get it down. 6SP4, same thing, displaying numerical data in plots on a number line, including line plots, histograms, and now finally box plots. I can display data using a box plot, and then we'll start to analyze a graph.
Another name for a box plot is sometimes called a box and whisker plot.
My favorite.
It's a goofy name, but as soon as you see what it looks like a box with whiskers popping out of the ends of it. You kind of see where the name came from, and it helps you kind of remember what it is. But a box plot is a diagram that's constructed using the median, which we talked about. That's the middle number in your list, and the first and third quartiles, which we talked about in our measures of variation lesson. That's the median of the lower half and the median of the upper half. The box is drawn around the quartiles, so our median's in the middle, quartiles on either end, and your whiskers extend from each quartile to the extremes. Your extremes are your highest and your lowest, your biggest and your smallest numbers.
Your greatest and your least, or your maximum and your minimum.
But basically, notice it broke the graph up into 4 equal parts. So I know it doesn't look like it's the same size, but 1/4 of the data falls in each of those 4 separate pieces, which is something we're going to be talking a lot about in the next couple of days.
Okay, our steps. Step 1, we're going to order them from least to greatest. And then, in order to graph it, we have to have every single number on a number line, whether we're going to use it or not. We need to make sure that it covers the range. In this problem, we want you to cross off the 12 and make it an 11, and we'll discuss that later on why we did that.
So first step is put them all in order. So I have 3, 4,
5,
5,
6, 7, 12.
11.
Oh, 11, yeah. That.
First thing we have to do is find the median, which is our middle number. So remember, you kind of sort from either end, and we get 5 as our median. Now we're going to sort the upper and lower half to find our quartiles.
Oh, I got it. It's 4 and 7. Ooh, that was easy.
So the middle of the lower half is my 4, if I kind of cross out from you. So that's my first quartile. 7 is the median of the upper half. Remember, the 5 is gone because we use that for our median. And then our extremes are just the highest and lowest. So we call this our lower extreme, and this is our upper extreme.
Now, step 3, we need to make sure that we put dots on every data point that we just highlighted. So there has to be a dot on the 3, please.
Now, do you put them on the 3, or do you put it above the line?
I put it above. What do you do?
I tend to draw it on there, but some people have a problem with that, so I wanted to be...
Yeah, I don't like to cover.
So our lower extreme is at 3. We have our first quartile at 4.
Yep, our median is at 5.
And then at 7 and
11.
The 3 in the middle, the quartiles and the median, are connected with the box. And then we draw our whiskers out to the upper and
Draw a vertical
lower
line through the quartile 1, median quartile 3, and then extend to each extreme.
Thank you for saying that so fancy.
I'm just reading step 3.
All right. So let's try another one here.
Putting the data in order, we have 23, 28, 28, 29, 30, 30, 2 34s, and a 36 to end our list. Hopefully we did that right.
Really? You checked it ahead of time, so I'm hoping we're good.
But it was in study hall, you never know.
All right. First, we find the median, the middle. So we kind of sort from either end. Remember, don't cross them out quite yet because you're going to have to go back and find your medians for the other half. So here's my median at 30.
So far, so good.
Now we're going to find the middle of the lower half. So in this case, it's going to be right between my 28s, which is at 28. Then the median, or the middle of the upper half. Again, it's going to fall between the 34s, so that's going to be 34. And then our low and our high. So our lower extreme is 23. Our upper extreme is 36.
Now, all those data points need dots either on the number line or above the number line, whichever you prefer. So
notice they're counting by 2s down here. So if you are someone who needs those written in, you can write in those other numbers just to help yourself.
All right, so 23 gets the dot, 28 gets a dot, 30 gets a dot, 34 gets a dot, and 36.
Oh,
what
sorry.
You doing, boy? 36 gets a dot. He's then going to make the box around quartile 1, the median in quartile 3.
So vertical lines through each of
change
them.
colors on you. And then he's going to extend the whiskers to the extremes. We are done.
So really all we're doing is finding those measures of variation, your medians and your quartiles. We added in one extra step of finding your upper and lower extremes, which is really just the highest and lowest number. They're already there on your chart. And then we're just plotting those points on our number line.
So 1/4 of the data is going to be between 23 and 28. 1/4 of the data is going to fall between 28 and 30. 1/4 of the data is going to fall between 30 and 34, and then 1/4 of the data is going to fall between 34 and 36.
That's the toughest part about a box and whisker plot is people tend to think because it's a longer section that means there's more data there. That's not true. If you look up here, there's only 2 data points below the first quartile. There's only 2 of them in between the first quartile and the median. There's only 2 more here and 2 more above the third quartile to the upper extreme.
But the longer the line, the more spread out that those 2 pieces of data are. So we're going to look at that when we learn to describe data in the next problem.
Next day.
There we go. Look, this one's already done in order for us.
Now take 1 second, take a look at that set of data. Does anything jump out at you that might be just a little off from the rest of the problem? Hopefully you notice that that 27 looks a long ways away from all the rest of these numbers. 6 and 8 and 10 are kind of close to each other. 11, 12, 14, 16 and 18 are still close, and then 27 really feels out of the ordinary. Keep that in mind. You probably can already think of what we're going to call that 27, but it's just something to watch for in these kind of problems.
Okay, step 1, he needs to find us our median. Since it's already in order, we need to skip ahead.
Sorry, I make dots slowly.
11 stands beside, and then 12 and above is the upper, and 10 and below is the lower. So he's crossing them off to find a quartile 3 of 16. And crossing them on the lower half to find a quartile 1 of 10. He also needs to label the 6 as our lower extreme, and the 27 is our upper extreme. So, in a visual way, 6 gets a dot. Now we got 9, 10, 11, 12, so be careful with that 10 dot.
It's going to be closer to the 9 than the 12.
Now you need next door to 11, so that should be the halfway point. And then 16.
Just past the
15. And then the 27.
And then our 27. You'll notice that 27 is way off to the side, so we're not going to connect that one quite yet. We want to make sure it really does fit with our data and make sure it's not an outlier. Remember, outliers from our measures of variation.
We need to go back to what we talked about with our outlier. Our outliers are found by taking our quartile 3 minus our quartile 1. And in this case, that's 16 minus 10, which is 6. Now, we're not done with subtraction. We have to multiply that by 1.5. So 6 times 1.5 is 9.
So that means then we can go 9 above 16.
So 16 plus 9 gives us our upper limit, which is 25. And 16 minus 9
and then 10
is...
minus 9.
Oh, I'm sorry, 10 minus 9,
First
which
quartile.
is 1.
So we don't have anything below a 1, so we have no outlier on the lower extreme. But 25 is the highest we can go without it being an outlier. 27 is clearly past that. So this 27 is going to be considered an outlier.
When we have an outlier, we need to go to the next closest data point to the 27, which is 18, and make 18 our upper extreme that we connect with a whisker.
So when we can't use that highest number because it's an outlier, we go to the next one on the list, in this case our 18, and that becomes the whisker instead. This one stays out here. Sometimes you'll see it written as a star.
Like, hey, I'm out here still.
Just a, hey, don't forget about me out here.
So look at the box plot in the above problem and describe the data. Well, what I see is in our, could you label the 1/4, 1/4, 1/4 for me?
About 25%.
Oh, wow,
25.
Thanks.
Well, sometimes you got to think of percents. I know
So
there's going to be a question on a test that's going to say that.
between the 25% that falls between 10 and 11 is very, very close together, where
So the data here is very close.
Where the upper part of the data is more spread out.
Notice how much room is here, even though it's still 25% of the data.
So somewhere in your description, you would look at your 25% and write a sentence about, the middle 25% is closer together than the upper 25%. There is an outlier that sits at 27, so we connected the box plot to 18. When there's an outlier, it needs to be addressed in that discussion when you're describing the data.
All right, last one is for you to do. So put your numbers in order. We'll let you know ahead of time there's no outlier that you have to worry about in this one, so everything's going to work together. Put your data in order, find your medians, your quartiles, and your upper and lower extremes. Create your box plot,
and
your
then
box and whisker plot.
On your own to describe the data using your 1/4 or your 25%, whichever you prefer.
So start kind of thinking about what is the sizes of those sections really telling you about the data in those parts.
See you tomorrow.